everyone, welcome back to the channel Unknown Physicist. So today we are in another video of our series Mastering MMP. So in our previous video we have discussed what is Laplace transform and we have done quite some of the really very important basics. If you have not watched those videos, the links are in description as well as in iCards. Do check and continue this video so that it will be easy and you will be able to understand it. So what we are going to see is today is again Laplace transform. We will be doing some more problems and some more higher order problems here. And if you're a new visitor to this channel, in this channel I do make videos on different concepts of physics. Right now I'm doing two series. One is for mathematical physics, other is for quantum. I've done quite good important topics in both these. You can check those playlists for your preparation. So let's get started with today's video. So before getting started with today's video, let us just have a glance what we discussed in our previous video. Laplace transform. So I have given 8 conclusions. So just let me write it again. So what was Laplace transform of 1? It is nothing but 1 by s. And the second one was Laplace transform of t power n, which was n factorial by s power n plus 1. And the third one is Laplace transform of e raised to at, which is 1 by s minus a. And the fourth one was Laplace transform of e raised to minus at, which is 1 by s plus a. And the next one was Laplace transform of cos at, which was 1 by, s by s square plus a square. And then sixth one was Laplace transform of sin at, which is s by, this is a, here it is s. A by s square plus a square. And the seventh one was Laplace transform of cos hyperbolic at, which was s by s square minus a square. And the eighth one was Laplace transform of sin hyperbolic at. So we have discussed how we arrived at all these expressions. So if you are not able to remember this, no problem. Just remember the way how we arrived at these expressions, then it will be easy for you. And one more important thing which I mentioned in last video was shifting theorem. Let me write here. Shifting theorem. So Laplace transform of e raised to at into f of t is nothing but the function is just replace your s with s minus a. Suppose Laplace transform of e raised to minus at into f of t. This was nothing but f of s plus a. So you have to replace your s with s plus a. So we have done nearly 3 to 4 problems over here. So hope you have done those tasks, so that only it will be really helpful for you. So let us see with today's video. So what we are going to see again today is shifting theorem. Shifting theorem. This is one of the really very important. Okay, very important. Try to listen carefully. So what do we know? Laplace transform of a function f of t is given by integral 0 to infinity f of t into e raised to minus st into dt. So this is nothing but your function s, right? So this is what we discussed in our previous video. So now what I am going to do is, I'm going to differentiate with respect to s on both sides. So how would it will be then? So this would be d by ds of integral 0 to infinity f of t into e raised to minus st dt is equal to d by ds of f of s. So which would be integral 0 to infinity f, like I'm getting the derivative inside. So into f of t d by ds of e raised to minus st dt is equal to d by ds of f of s. So once I differentiate, what I will be getting? Integral 0 to infinity minus t into e raised to minus st into dt is equal to d by ds of f of s. So I'm getting the minus on other side. So this is nothing but integral 0 to infinity t into e raised to minus st dt is equal to minus d by ds of f of s, right? So what is this? This is nothing but Laplace transform of t into f of t, right? T into f of t, so which is equal to minus d by ds of f of s. So Laplace transform of f of t is what? It is represented as f of s. So if you have Laplace transform of t into f of t, then it is minus d by ds into f of s. Okay, fine. Now I am having Laplace transform of t square f of t. T square f of t. Then this is nothing but minus 1 the whole square into d square by ds square into f of s. D square into, sorry, d square by ds square into f of s. So in general I can write this as, one second. So I'll erase over here. So just I'm making your problem easier by showing this way, okay? So we will solve a quite number of problems. This will be really helpful. So this is what I got. So from this I can write this generally as, if you have a function Laplace transform of t power n into f of t, then it is nothing but minus 1 whole power n into d power n by ds power n into f of s. Again, I'm repeating, this is one of the really very important. If you are able to look at your previous year questions of any competitive exams, there will be at least one question of this type. One question of this type. So you should be very careful. So now we are going to solve a lot of problems. So here comes our first question. So our first question is Laplace transform of t into s80. Sorry, t into sin 80. It is not s. It is t into sin 80. So first let me find what is Laplace transform of sin 80. It is nothing but a by s square plus a square. This is s. Sorry, s. Okay. It is nothing but a by s square plus a square. Right? Now I need to find Laplace transform of t into sin 80. So what is the form for it? It is nothing but minus 1 whole power n d power n by ds power n into f of s, right? So what is this n? So n represents your power of t. So what is n here? It is 1. So which will be minus 1 whole power 1 into d by ds of, what is your f of s? It is a by s square plus a square. So now I have to differentiate it. So this would be minus 1 into minus a by s square plus a square the whole square into 2s, right? So once you differentiate, you will be getting this. So finally, Laplace transform of t into sin 80 is nothing but, so here it will be 2 minus into minus plus, so 2as by s square plus a square the whole square. Hope you got it. So it's just basic differentiation involved over here. So here as a task, so this is your first question. So here as a task, do it for Laplace transform of t into cos 80. T into cos 80. So just, it is similar to this, okay? It's very easy. First find what is Laplace transform of cos 80 and just substitute in this formula and find what your answer is. So the next type of problem, we'll see something different. So this will be my third one. So Laplace transform of t square into cos 80. So t square into cos 80. So first what I'll find what is Laplace transform of cos 80. It is nothing but s by s square plus a square, right? So next is Laplace transform of t square comma cos 80. So which would be minus 1 whole power n. So n here it is 2. So minus 1 whole power square into d square by ds square into s by s square plus a square. So we have to do double differentiation. So be careful with it. So which would be d by ds of s square plus a square into 1 minus s into 2s divided by s square plus a square the whole square. So if I simplify this, this would be d by ds of s square plus a square minus 2s square divided by s square plus a square the whole square. So it's your way of doing differentiation. You can simplify it if you are comfortable. So next is d by ds of, I'm writing the numerator as a square minus s square. Okay, this is nothing but a square minus s square by s square plus a square the whole square. So if you want to give a try, just pause the video and check after some time what answer you are getting. Okay. So now I have to do differentiation for this. So which would be s square plus a square the whole square minus, sorry, into minus 2s minus a square plus, I'm sorry, a square minus s square into 2 into s square plus a square into 2s, right, divided by, this is differentiation of s square again, divided by s square plus a square the whole power 4. So now if you look, you can cancel here commonly. 1 s square plus a square over here, and there is 1 s square plus a square. So this becomes cube. So what I'll have here is s square plus a square into minus 2s minus a square minus s square into 2s divided by s square plus a square whole cube, right? I'll just cancel these terms. So let me expand this, and I can take 2s common from the numerator. If I'm taking 2s common, then it is 2s into s square plus a square into minus 1 minus 1 minus once again here I have left this 2 over here. Sorry, I have left this 2. So this should be minus 2a square plus 2s square divided by s square plus a square whole cube. Let me erase this half of the screen and proceed. One second. So in these steps, you should be really confident with your differentiation, and for that you need to have a lot of practice. So for example, this sum itself, you can practice for more than 2 to 3 times so that you will be like able to recognize, okay, if I'm able to recognize such type of function, I have to differentiate it this way. You will be getting an idea than being blank in exam. If you are having a practice for more than 2 to 3 times, you can really master it. So now this would be 2s into, so what I'll be having, like if you are doing all these algebraic things, you will be getting s square minus 3a square, right, divided by s square plus a square whole cube. So this will be your final answer. So there might be some conditions given in your exams, like find what if s is equal to a. So do try for this question, what if s is equal to a. So then this would be 2s into s square minus 3s square divided by s square plus s square the whole cube. So which would be 2s into minus 2s square divided by 2s square the whole cube. So which would be, the numerator is minus 4s cube divided by 8s power 6. Sorry, this is yes, 8s power 6. So finally I'll be having minus 1 by 2a cube. If they are giving some conditions like this, like when s is equal to a, find what is your Laplace transform of t square comma a cos at, something like it, or s is equal to 2a. It completely depends on your question. So you should be aware how to do this. So as a task, I will give you one problem over here. So this is my fourth question. So this is a task. So the question here is find the Laplace transform of t square comma sine 80. T square comma sine 80. So you have to just find this. No need of all those conditions. So just try to find what is your answer. I think it will be a little bit lengthy answer, but that's okay. You can share your answers in the Telegram group, which is unknown physics. Sure, I will be happy to help you guys over there. So let us see the next question. The next question is question number 5. So find what is the Laplace transform of t into e raised to minus 80. T into e raised to minus 80. So first, what is the Laplace transform of e raised to minus 80? So this is nothing but 1 by s plus a. So now I have to find Laplace transform of t into e raised to minus 80. So your n here is 1. So minus 1 whole power 1 d by ds of 1 by s plus a. So this would be minus 1 into 0 minus 1 divided by s plus a the whole square. So which would be Laplace transform of t into e raised to minus 80 is nothing but minus 1 into minus 1, it is plus 1 by s plus a the whole square. S plus a the whole square. It's quite simple, right? So here I am going to add two more tasks. I'm going to add two more tasks. So this would be question number 6. So question number 6 is Laplace transform of t comma e raised to 80. T comma e raised to 80. And the seventh one is Laplace transform of t square comma e raised to 80. T square into e raised to 80. These are very quite simple. And one more thing what I would like to convey over here is uh, you will not expect Laplace transform only in your mathematical part. Actually, Laplace transform has a quite important, like, how to say, you can save a lot of time by having this Laplace transform in quantum mechanics. So for example, there was previous year questions from first order energy correction, and similarly in scattering amplitude. In all those regions, this Laplace transform will be really helpful. So for that, first you need to master the basics of Laplace transform. I have not covered those first order energy correction or else scattering amplitude. So I'm not mentioning all those problems here because it will be too tough for you to understand those concepts right now. So when I'm doing those concepts, sure, I'll be explaining you all these things, how they are used in quantum mechanics, right? Hope that's it. So just give a try to these tasks and mention your answers. If you have any doubt or else if you have not understood anything, please do mention in the comment section. I would be really happy to help you guys. And if you are an aspirant who is preparing for just 2021, please make sure you are reading all these concepts like complex analysis, Fourier series and Fourier transform, as well as variational principle. These four are quite important in point of just exams. I have done those videos. Do check those videos also. So I'll be posting a YouTube shorts which has questions based on Laplace transform tomorrow morning. So don't forget to check those things also. So still then everyone keep practicing, and if you appreciate the content went in this video, don't forget to hit the thumbs up sign. So bye bye everyone. Have a nice day.